So now we're looking at the guided practice for example 1, and we want you to be able to graph the hyperbola given by this equation here. So see if you can first identify the center of the hyperbola, and then the values of a and b so that you can find the vertex. Then you want to find the focal length so you can plot the foci, draw in your asymptotes, and complete the graph. So go ahead and pause the video now, graph this, and then check your answers when you resume the video. So you should have found that C was the correct answer. A hyperbola which opens facing up and down, the vertex is going to, the center is going to be at -1, 3. And then you're going to go up 8 spaces up and down and 7 spaces right and left to make your box. All right, so graph the hyperbola given by the following equation. You'll notice that this equation doesn't look like standard form. And so you're going to need to make it into standard form. And the way we do that is through the process of completing the square. So there's the original equation. And we need to isolate and group like terms. So notice that we've collected all the x values here. And then you can also collect all the y values over here and then move the constant to the opposite side. Okay, and then we need to factor. So here we've taken a 4. Here we've taken a 4 out from these two terms. And here we've taken a -1 out from these two terms. And the reason why we factor is because we're going to be completing the square. So completing the square from here, remember that you take the middle term, 6, cut it in half and square it, and that's where the 9 comes from. So same thing over here for y. Take the linear term 4, cut it in half and square it, and you get 4. Be really careful that you remember that because you actually added -4 right here, that you put -4 to the other side, and that because you added 36 right here, that you're adding 36 to the other side. So now these two trinomials that are both perfect squares, we're going to write both of these in factored form. This guy factors into x plus 3, quantity squared. And this guy right here factors into y minus 2, quantity squared. And then we're almost finished. Remember that in order to be in standard form, the hyperbola should be equal to 1. So this guy over here needs to be a 1. So how can you turn a 60 into a 1? You can divide by 60. So we divide by 60 on both sides, and this is the final form of the equation that we get. So what do we have here? Well, we know that the center is going to be at -3, +2, right? That's the center. That's our h and our k. We have an a value, which is the square root of 15. We have a b value, which is the square root of 60. And then we can plug a and b into our equation for the focal length and solve for c. And then we should be able to graph the hyperbola at this point. So here again is a summary of all of the things that we have for this hyperbola. And if I was going to graph this, I would start by plotting the center, -3, 2. I would draw the box, right? So going out the square root of 15, out the square root of 15, and you're just going to have to estimate that on your graph. And then up and down the square root of 60, right? And then this is the box that I get. Right, so there are my asymptotes, which are passing through the box. And then when I graph my hyperbola, I put my pencil on the vertex, and then I just go out toward the asymptotes. Pencil on the vertex, out toward the asymptotes. Don't forget to plot your foci, right? They're sitting way out here. You are going to have to solve, remember, for this focal length here, the distance from the center out to the focus, using a squared plus b squared equals c squared. Okay, so guided practice. So your turn. I'd like you to take this equation here and rewrite it in the standard form for a hyperbola. Remember to group the like terms, factor out the leading coefficient for the quadratic terms, and then complete the square. And then make sure that you divide by whatever you need to divide by so that the whole equation equals 1. So go ahead and try that now. Pause the video. When you're done, you can resume the video and check to see if you got the correct answer. So you should have found that the correct answer was B. This is a hyperbola which is opening up and down and has a center at 5, -2. All right, so now we're going to practice writing equations. So they're giving us some characteristics, and our job is to write the equation for it. My advice for these problems is the best thing you can do is just start plotting things. So, for instance, they tell us that the foci is at 1, -5. So let's plot 1, -5. That's one of my foci. So I'm going to mark that and call that guy F for foci. And then the other foci is at the point 1, 1. What I noticed right away about my foci is that they're sitting on a vertical line together. That tells me right away that the hyperbola is going to open up and down. The other thing I notice about the hyperbola is that the center of the hyperbola should be sitting exactly halfway in between the two foci. So that puts it right here. So there's my center. So the center is going to be at 1, -2. I also know that this hyperbola is going to open vertically. So it's going to look like this. Y minus 1 squared minus x minus a minus 2, x plus 2 squared equals 1. So I put my h and my k into my equation. Right here. Oops, I've got these in the wrong spot. Let's switch those. Good catch for myself there. This one goes with this guy, and this one goes over here. All right, good catch. All right, and then the next thing that I need to do is I need to use this bit of information right here. It says that the transverse axis length is 4 units. And that means that the size of the box, right, is 4 total units tall. Like this is 4 units. What that tells me is that A is 2, right? 2 units up and 2 units down. So since that's a vertical distance, it goes underneath Y, 2 units up and 2 units down. So what I need to solve for is this guy, right? So we'll call that B. What I know in my problem is that my focal length is actually 3. So if C equals 3 and A equals 2, how do I solve for B? Right, we're going to use the Pythagorean theorem. C squared equals A squared plus B squared. That means 9 equals 4 plus B squared, and I get B squared equals 5. So that means that I can go back here, right, and I can replace this B squared with 5. And that is how I'm going to find that equation. So quick summary of what I did. I used the x-coordinates of the foci to recognize that this was vertical, And then I found the center by looking at the midpoint exactly between the foci. So that's how I found the center. It was the midpoint between the foci. Then because they told me that the transverse axis was equal to 4, I concluded that I went up 2 and down 2. In other words, A was 2. I also knew that the distance from the center to the focus was 3, so that gave me C. And the last thing I did was I plugged C and A into the equation to find the focal length, and I solved for B, which was the square root of 5. Then you can take all of these things and plug them into the equation, right? So this was A squared, this was B squared, this was H, and this was K. And I made sure that when I wrote this, the Y came first because this was a hyperbola that opened up and down. So that's my final answer for this problem. Okay, so let's take a look at another example. This one says, write the equation for the hyperbola with vertices at -3, 10 and -3, 2. Okay, so -3, 10, I'm not really going to be able to draw this on here, but -3, 10 and -3, 2. So again, what I notice about these is that they are on a vertical line together. This is going to be another hyperbola which opens up and down. And this one, I'm going to do the same thing I did last time. I'm going to look for what point is exactly halfway in between -3, 10 and -3, 2. Right? And that's going to be the point -3, 6. Okay. That's the center right there. And that means that this focal length is 4. Last time they told me the transverse axis had a length of 4. This time they're telling me that the conjugate axis has a length of 6. That means that from the center I went out 3 spaces this way and out 3 spaces this way. So they're giving me B is 3. I also know that C is 4. And I'm going to have to solve for A. Right, A, what distance do I go up and down from the center to find the vertices? So it opens up and down. I'm going to do, the center is at -3, 6, so that's my H and K. I'm going to do Y minus 6, right? This guy goes here. Minus X minus a -3 or +3. This guy goes here. The value that I went up and down to find the vertices is unknown, right? That's my A squared. The value that I went right and left, that's my B. So that would be 3 squared. So I'm going to use these 3 guys together. C squared equals A squared plus B squared to solve for A squared. So I get 16 equals 9 plus B squared. 16 minus 9, I'm going to get B squared equals 7. Okay, so that means that this guy right here should go up here, right? So now I can replace this guy with 7. So quick summary, again, what I've done. I found the x-coordinate, right, of the foci to be the same, which meant the transverse axis is vertical. This is opening up and down. So exactly halfway between these 2 points, in other words, the center between the vertices, I'm going to find that the center was at -3, 4. And the conjugate axis is 2b. They told me that was equal to 6. So that told me I went 3 spaces in each direction from the center. So b is 3. And then the distance from each vertex to the center is 6. So again, this is H and this is K. This is the distance up and down that I traveled, 6 spaces up and 6 spaces down. This is the distance that I traveled right and left. And I plug those into my equation and I solve. So that's the equation for this one. So now you're going to try this one on your own. Go ahead and pause the video, see if you can graph these and find the equation, and then when you're ready to check your work, resume the video. So you should have found that the correct answer here was D. All right, last thing we're going to look at is how to tell what kind of conic section you have by looking at the equation in standard form. And just like when we had a quadratic and we wanted to know how many roots or types of solutions we would have for a quadratic, we'd use something called the discriminant, right? So the discriminant is b squared minus 4ac, and it turns out that the discriminant for conics is the same. So b squared minus 4ac will be less than 0, or in other words, negative, if the conic is going to be a circle. If b squared minus 4ac is negative and b is not equal to 0 and a is not equal to c. In other words, these terms right here, the quadratic terms that you have, they should be different in an ellipse. Okay, so we would say that the quadratic terms are not the same. Okay, if your discriminant is exactly equal to 0, then you will find that you have a parabola. And lastly, if the discriminant is greater than 0, you'll have a hyperbola. The two that you're going to probably get confused on a little bit are these two. And so you're going to need to recognize that one has b is equal to 0, in other words, an xy term, and this one you have b not equal to 0. So this one has no xy term, and this one has an xy term. Or the a and the c, the leading coefficients of the quadratics, are not 0. So use the discriminant to identify the conic. So what are we looking for? Well, we can check the discriminant, right? So a is 2, that's your a, that's your, there is no b, that's your c. There's b right there, oh, there's b. And then c is equal to 1, right? That's a 1. So plug those into your discriminant, and you get 17. So there the discriminant is greater than 0. And if the discriminant is greater than 0, then the conic's a hyperbola. All right, let's try it again. This is a, b is 0, because there's no xy term. Right, this is c. This time you notice that a and c are the same, right? So we'll find the discriminant, we get negative 64. So this is the one where we're like, oh, is this a circle or is this an ellipse? But remember, the way we were going to tell was if this was an ellipse, these two numbers should be different. But since they're the same, then we would find that this is a circle. Use the discriminant to identify the conic. So again, here's a is 2. This is c is 2. And this is b is 4. So we're going to plug those three values into the discriminant, and we get the discriminant is 0. So right away we're going to identify this as being a parabola. It can be helpful to know what kind of conic you have, so that when you're in the process of putting it in standard form and you're completing the square, you're anticipating what the equation should look like. Okay, so this is the guided practice for the last thing here. So you're going to try to put this guy, A, B, and C, identify them, plug them into the discriminant, and see if you can determine if it's an ellipse, circle, hyperbola, or parabola. Pause the video, see if you can solve it, and then when you're ready to check your answer, resume.